Since we just took the indefinite integral, let's try a definite integral. So let's go negative pi to pi, because that's using full wavelengths of sine x, but that's one full wavelength of sine 1x. It's 3 full wavelengths of sine 3x, but at least it's full wavelengths, not just partial wavelengths. I'm going to do something interesting here and multiply by 1 over root pi times root pi. Since that gives us the correlation, don't worry about it, but it's just kind of an interesting connection. You'd notice that this, like, multiply a definite integral by 1 over something looks a lot like how we would take the average. We would do the upper bound minus the lower bound, so pi minus pi. But that would give us 1 over 2 pi, and here what we have is 1 over pi. So what we're doing is like an average, but it's off by a factor of 2. Anyway, we just took the indefinite integral of this, so we don't actually have to go redo that. We can just copy it from the previous page. So here's the indefinite integral, and now go ahead and try plugging in pi and negative pi and subtracting and see what you get. It's actually, I know usually I say just throw it into a calculator, but here it actually is kind of interesting to see what happens. So go ahead and do that and come back. Ready? So we have 1/2 sine of 2 pi minus 1/4 sine of 4 pi minus 1/2 sine of negative 2 pi, or negative pi times 2, minus 1/4 of sine negative 4 pi. Need a bigger camera here. And what does that all end up being? 1 over pi, 1/2 times sine of 2 pi. Well, sine has hit a full wave by that point. It's back to 0. So that's 0. What is sine of 4 pi? That's 2 full waves. We're back to 0. And then sine of negative 2 pi, again, full waves. We're back to 0. And sine of negative 4 pi, that's 2 full waves going backward, and we're back to 0. So altogether, this is 1 over pi times 0. So the question, how correlated are sine 3x and sine 1x over full wavelengths? Apparently their correlation is 0. They're not correlated at all, even though they're both sine waves. Kind of interesting. Would that always happen, do you think? Let's write that down. Do you think we had like sine mx times sine nx, let's say for integers m and n? Do you think that always gives a correlation of 0? Can you imagine a situation where these two might be perfectly correlated with each other? You'll be exploring all that kind of fun stuff in the homework. But in the homework, you get to do these integrals graphically. I mean, there's one homework problem where you have to do the integral using trig identities and plugging in and stuff. But for a bulk of the homework problems that are like this, I really strongly encourage you to skip the by hand calculus. Just graph it and say, can I argue that the area is 0 here? Can I argue that the area is definitely not 0? Even eyeball it what it is and be fairly sure that that's exact. So that big batch of exercises, you should really be doing those by graphical analysis. You can throw the integrals into Wolfram Alpha or something, or Desmos, if you want to check the exact answers.